Hi, welcome to my YouTube channel on designing and building ML systems. My name is Manoranjan Pradhan. In this week's video, we'll discuss about the importance of building model baselines. So when you start the model development process, some of the questions that may come to your mind is, should you build the most complex model available because that promises better accuracy? Is the current accuracy of the model enough? What is by enough? What is the minimum expected accuracy of the model for it to be useful for deployment? Do we need more tuning, like hyperparameter tuning or fine tuning? Do we need more data or features to further improve the accuracy of the model? So whenever these questions come to your mind, one of the basic guiding principle is always choose simplicity whenever possible, or choose complexity only if it gives significant advantage over simplicity. Because we all know the disadvantages of building complex models, because it may lack interpretation, or it may lead to higher cost of deployment or higher risk of deployment. Then how do you know how good the model is? How to measure is the model better or not? Recommended approach in ML ops is to always start by building a baseline model and then slowly move towards building more advanced and complex models. Because baseline model gives the lower bound on expected model's performance. So your more advanced and complex model should at least give this performance or better. And then also helps us understand if the model's performance, the advanced or complex model that you're building, whether its performance is higher or significantly higher compared to the baseline model or not. And based on certain criteria like what is the expected accuracy for deployment, what is the cost of deployment, and its ability to interpret or explain the model. But then how do you build baseline models? There are many approaches to build baseline models. Like you can actually build a baseline model using simple heuristics. So when you talk to domain experts or subject matter experts, you can derive certain rules from their intuition and then write those rules to classify or predict. If you are building an employee attrition model and the domain experts say if the satisfaction level of an employee, which is typically measured through a survey, falls below a certain threshold value, the employee is likely to leave. So you can derive certain rules from the domain expert's intuition and build a system or a program based on the heuristics and apply to the test data and measure its performance. And then build a complex model and compare the performance of the model with these heuristics. Similarly, you can also build a baseline model using zero rule baseline, which is a simple case of heuristics. For example, if you are recommending a product, you can recommend the most purchased product in the last 24 hours or last 7 days in a particular journal, and then look at the conversion rate. Or if you are building a forecasting model, first build a model using simple moving average or exponential smoothing, and then move into more advanced time series models. You can also use human baseline, how humans would perform, not the expert annotators or labelers. You can actually measure the performance of the humans through crowdsourcing, mostly used in NLP and vision based problems. For example, self driving cars should perform at least better than human drivers. Or build a simple ML model, especially when deriving these heuristics are not feasible. You can use models like linear regression or decision tree with a limited set of features, like features which are highly correlated with the outcome. There's a wonderful blog which says Google's rule for machine learning. So there are about 40 rules they have published as a guideline to build machine learning models. The first rule says, don't be afraid to launch a product without machine learning. And they have suggested using heuristics to build a baseline model. It says, theoretically, you can take data from a different problem and then tweak the model for a new product, but this will likely underperform basic heuristics. So developing baseline model using heuristics is a very popular approach. So let's see what leading practitioners say about building baseline models. So one of the leading ML engineers in GitHub, Hamel Hussein, says it's important to do it without ML first. Solve the problem manually or with heuristics. This way, it forces you to become intimately familiar with the problem and the data. This is one of the significant advantages of building baseline models with heuristics, because it compels you to communicate with the business or domain experts and also do a better job in exploratory data analysis, which ultimately helps later in building a better and a robust ML model. Another tweet says, I have gotten so much flack for this. One project I did with string comparisons, but customer was disappointed. I did not use neural networks and hired someone else to do that. Guess which one was cheaper and more accurate? There are many instances like this where building a baseline model helped organizations understand if at all they need an ML model or they don't need an ML model. Or if they need an ML model, how better it is in performance compared to the basic heuristics or traditional systems. This also helps organizations have more trust on ML models and helps adopt and deploy ML models. So I will leave you with this wonderful quote from a leading statistician who says, essentially all models are wrong, but some are useful. And baseline models actually help you to understand the usefulness of a model from the perspective of the expected accuracy, the cost of deployment, and ability to interpret. So in this week's video, we discussed about the importance of baseline models. Thank you for watching this video. I'll see you in the next video with a new topic. Thank you.